Some soil have been given the term problematic soil. This is because they are troublesome to be used as a base for any construction or foundation due to the factors such as soil movement, which can cause excessive settlement. One of the examples of soft soil is clay. Clay is categorized as soil with a low shear strength, high compressive rate and very low permeability. Therefore, soil improvement must be made. So, the examples of soil improvement is geosynthetic materials. Geosynthetic materials has a wide range of use in construction, either to reinforce soil or to stabilize any slope. The examples of geosynthetic materials are geotextile, geogrid, and geomembrane. So, clay also has a low permeability and high moisture content. This means that clay can retain the water through its tiny particles. This causes the soil to have high compressibility rate and can contribute to the problems such as excessive settlement after construction. So the goal of this project is to propose a soil improvement method to reinforce an embankment constructed on soft soil. Therefore, the following objectives must be met. First is to study the characteristics of problematic soil. Second is to create a 2D model using Plaxis 2D software. And third is to simulate the 2D model's settlement before and after soil improvement.
For the literature review, as we know, ground improvement is mainly carried out to improve the bearing capacity and to reduce the settlement. Various ground improvement techniques are largely available nowadays. So, soil reinforcement method is one of the most popular ground improvement techniques. The reinforcement method can be in the form of vertical reinforcement like piles or stone column, or horizontal reinforcement like soil nailing and geosynthetic products. Sometimes they may be expensive. However, nowadays many researchers using bamboo foundation for soil improvement on soft soil. For example, bamboo piles is used to stabilize soft soils and reduce building settlement, and according to Marto, bamboo can distribute embankment load uniformly. So the bamboo that laid in square position, they forms an interlock or pocket that creates an increased stiffness of bamboo, which distributed vertical pressure evenly and could minimize differential settlements. So this figure shows the bamboo in square pattern.
We refer to article named Numerical Analysis of Bamboo Geotextile Composite Reinforcement Embankment on the Soft Soil, which is the study at the UTHM Batu Pahat. Okay, in this study, as shown at the beside, soft soil have a 3 layer, which is the clay layer 1, clay layer 2 and the clay layer 3, which is the clay layer 1 have 4 meter, clay layer 2 9 meter and the third layer is 3 meter, which is every layer has their own parameter and their own characteristic, which is we have proposed for the 3 layer, which is the Y unsaturated, Y saturated, Kx, Ky, lambda, kappa, C prime and the degree of the consolidation, which is the 3 layer of parameter, the 3 parameter layer of the soil have their own value and their own characteristic, which is, and also for the improvement for the soft soil layer, which is we propose the bamboo foundation. So we use at the Plaxis 2D, which is the EA value is the 14,000 kN per meter. Alright, this is our proposed model as stated. Alright.
Hi, my name is Muhammad Shafiq and I will present to you about the discussion. There are 2 types of model that have been constructed by Plaxis 2D, which is embankment without soil improvement and embankment with soil improvement by using bamboo foundation. From the Plaxis 2D, the settlement of the clay soil have been constructed and calculated at first point 00 and second point 80 under the embankment. The comparison of the first point 00 settlement for embankment with and without soil improvement are discussed. So, the embankment without soil improvement face more settlement value compared to the embankment with soil improvement. At the first point, which is 0.6 meter and 0.5 meter respectively, as shown in the graph. While the second point, 8.0, have a different result pattern, which is at the first point, which is 0.15 meter for without soil improvement and 0.16 meter for the soil improvement as shown in the graph. This pattern occurs because of without soil improvement consolidates in a very long time compared to with soil improvement. For excess pore water pressure, data have been obtained from Plaxis 2D. The coordinate that have been selected from three different places or three different layers, which is at point C 4.2, point D 4.8.5, and point E 14.5. During the consolidated time, which is 30 days, the pore water pressure discharge faster in construction phase 2 compared to construction phase 1. This is because the thickness of the clay soil in construction phase 2 is reduced compared to in construction phase 1. These two graphs show that without soil improvement, discharge water more rapidly compared to with soil improvement. This is because soil improvement with bamboo foundation create a void between clay soil and the bamboo.
So, from the data and analysis by modeling in Plaxis 2D, the bamboo foundation which had been modeled could be able to distribute load uniformly, though clay soil has very low permeability and high compressibility, which affected of the soil settlement behavior. Since slightly improvement in settlement behavior is analyzed with the presence of bamboo foundation, thus bamboo foundation able to provide improvement in the clay soil sublayer. For the analysis of excess pore water pressure distribution of the proposed embankment model on the clay soil, it showed that it was completed at the end of completion of settlement in the Plaxis 2D and returned to zero for all 3 points that has been analyzed, which is point C, point D, and point E. Based on the analysis, the value recorded for embankment model before modeling the bamboo foundation was higher compared to the value recorded after modeling the bamboo foundation. It can be concluded that the bamboo foundation could create a void between the clay soil and the bamboo. As recommendation, since the properties of bamboo used for modeling bamboo foundation use was untreated bamboo, it could be replaced with the properties of treated bamboo. This is because treated bamboo had higher tensile strength compared to untreated bamboo. Next, for the proposed embankment design, since only recorded slightly change between the design before placing of bamboo foundation and after placing 3 layers of bamboo foundation, other ground improvement method might be considered or implemented towards the embankment design. For suggestion, PVD and geotextile could be applied in the clay soil. This improvement method could increase the rate of consolidation and could reduce the settlement in the soft soil.